You may by now be familiar with the notion of evaluating a function at a particular value. So for example, if this table is our function definition, if someone were to say, well, what is f of negative 9? You'd say, okay, if we input negative 9 into our function, if x is negative 9, this table tells us that f of x is going to be equal to 5. And you might already have experience with doing composite functions, where you say f of, let's say actually f of negative 9 plus 1. So this is interesting. It seems very daunting, but you say, oh, well, we know what f of negative 9 is. This is going to be 5. So it's going to be f of 5 plus 1. So this is going to be equal to f of 6. And if we look at our table, f of 6 is equal to negative 7. So all of that is a review so far. But what I want to now do is start evaluating the inverse of functions. And this function f is invertible because it's a one-to-one mapping between the x's and the f of x's. No two x's map to the same f of x. And so this is an invertible function. So with that in mind, let's see if we can evaluate something like f inverse of 8. What is that going to be? And I encourage you to pause the video and try to think about it. All right, so f of x, just as a reminder of what functions do, f of x is going to map from this domain, from a value in its domain, to a corresponding value in the range. So this is what f does. So this is domain, and this right over here is going to be the range. Now f inverse, if you pass it the value in the range, it'll map it back to the corresponding value in the domain. But how do we think about it like this? Well, f inverse of 8, this is whatever maps to 8. So if this was 8, we have to say, well, what mapped to 8? Well, we see here f of 9 is 8. F of 9 is 8. So f inverse of 8 is going to be equal to, and actually we do this in that same color, is going to be equal to 9. And if it makes it easier, we could actually construct a table here. And this is actually what I probably would do, just to make sure I'm not doing something strange, where I could say x and f inverse of x. And what I'd essentially do is I'd swap these two columns. So f of x goes from negative 9 to 5. F inverse of x is going to go from 5 to negative 9. All I did is I swapped these two. Now we're mapping from this to that. So f inverse of x is going to map from 7 to negative 7. Notice, instead of going from this, mapping from this thing to that thing, we're now going to map from that thing to that thing. So f inverse is going to map from 13 to 5. 13 to 5 is going to map from negative 7 to 6. Negative 7 to 6. It's going to map from 8 to 9. 8 to 9, and it's going to map from 12 to 11. From 12 to 11. So let's see, did I do that right? Yeah, it looks like I got all of, yep. So all I did is really I just swapped these columns. It's mapping, the f inverse maps from this column to that column. So I just swapped them out. So now it becomes a little bit clearer that way. And you see it right over here. F inverse of 8, if you input 8 into f inverse, you get 9. So now we can use that to start doing fancier things. We can evaluate something like f inverse of, actually let's evaluate this. Let's evaluate f of f inverse of, let's see, f of f inverse of 7. What is this going to be? Well, let's first evaluate f inverse of 7. F inverse of 7 maps from 7 to negative 7. Maps from 7 to negative 7. So this is going to be f of this stuff in here. We do it in yellow. This stuff in here, f inverse of 7, we see is negative 7. So it's going to be f of negative 7. And then to evaluate the function, well, f of negative 7, that's just going to be 7 again. And that makes complete sense. We essentially we mapped from 7, f inverse of 7 went from 7 to negative 7, and then evaluating the function of that went back to 7. So let's do one more of these, just to really feel comfortable with mapping back and forth between these two sets, between applying the function and the inverse of the function. So let's evaluate what, do it in purple, f, I mean, no, that wasn't purple, so it's going, let's try to evaluate f f inverse of f inverse of 13. Of f inverse of 13. What is that going to be? I encourage you to pause the video and try to figure it out. Well, what's f inverse of 13? Well, that's looking at this table right here. F inverse goes from 13 to 5. And you see it over here. F went from 5 to 13, so f inverse is going to go from 13 to 5. So this right over here, f inverse of 13 is just going to be 5. So this whole thing is the same thing as f inverse of 5. And f inverse of 5, well, f inverse goes from 5 to negative 9. So this is going to be equal to negative 9. Once again, f inverse goes from 5. F goes from negative 9 to 5, so f inverse is going to go from 5 to negative 9. So at first when you start doing these kind of inverse and function and inverse of a function, it looks a little confusing. Hey, I'm going back and forth. But you just have to remember, a function maps from one set of numbers to another set of numbers, and the inverse of that function goes the other way. So if the function goes from 9 to 8, the inverse is going to go from 8 to 9. So one way to think about it is you just kind of switch these columns. Hopefully that clarifies more things than it confuses.